Okay. So number 5. So how are we going to get rid of that y cube on the right-hand side? How are we going to get rid of it? Cube root. Very good. So I continue, and I'm going to do the cube root. Thank you for your patience. Of the fraction equal to the cube root of that side. I continue. Now, on the left, something really nice does happen. Can't you do the cube root of 8? What's the cube root of 8, guys? Just plain 2. So that comes out. So I'm going to do the cube root of the top, which was x plus 3. And the bottom is just plain 2. And then this is equal to the answer. So G inverse X. Okay, so it's just that bottom part simplifies, so you might as well. All right, so down to number 6 here next. She okay? Yeah, okay. Thank you. So number 6. So we're gonna go 1 divided by 2x minus 3. So step 1, I'm gonna take h of x and I'm going to rewrite it as y equals. Next, I'm gonna switch x and y. So I have x is equal to 1 divided by 2y minus 3. And I'm immediately going to cross multiply that. So I get 2xy minus 3x, if I distribute, is equal to 1. My goal is to always solve for y equals. So what should happen next, guys? Yep, add the 3x. Excellent. So I get 2xy equal to, if I add that over, 1 plus 3x. Coming to the end. What do I do to get y by itself? Yep, divide by 2x. Excellent. Divide by 2x, divide by 2x, and you are done. So divide by 2x, divide by 2x, which gives me a final answer of y is equal to 1 plus 3x divided by 2x. Oh, I gotta switch my notation. I'll do this since I already wrote y. There we go. So I don't have to limit that, that's fine. Okay, now moving on to something like number 7. You're gonna notice something different here. You guys see it? Do you notice how you have 2 x's? Okay, when you go to make the switch, you do switch all of them, okay? So I'm going to immediately change this to y equals. I'm going to switch x and y. So I replace both of them. So replace both of them. Now I'm going to cross multiply and solve. So I'm going to go over 1 and multiply. So this times this. So 5x minus xy is equal to 2y minus 1. So this type of question is a little bit more involved than the inverse ones we did above, because you're going to see that there are y's located in 2 of these terms. So what I need to do now is I need to get my terms with the y's on one side and everything else on the other. It doesn't matter what side you push things to, you just have to make a move. So I'm going to do this just to get rid of the negative. So I'm going to move this one over here. I'm going to put it right there. And while I'm at it, I'm also get rid of that 1 and add the 1 over as well. So I've manipulated my equation to say 5x plus 1 equal to 2y plus xy. The next step is not the most natural for students to usually see. Anyone have an idea what we can do on the right? Yes, excellent. Greatest common factor. Awesome. You're going to take a y out and make it look like this. Because then you can divide that expression over. Awesome. Yes, this type is going to require a greatest common factor right here. So it got a little bit tougher on you. So you're going to divide by 2 plus x, and then you're done. Divide by 2 plus x, and you're done. I get y is equal to 5x plus 1 divided by, oh, I keep doing that, so I'll just do this again. And then divided by 2 plus x. You can keep parentheses around it or not. It doesn't make any difference whatsoever for that. Okay. How do we feel in all those inverses so far? Wonderful. Now here's the hard ones. To do these next couple inverses, you have to know something. And by know something, you need to know what the inverse is going to look like. So letter A is an exponential function. So guys, how did we typically, go from an exponential function to something else? What were we doing last week? I want to say it without giving it away. What went with exponent? Log. Awesome. So exponential and logarithmic functions are inverses of each other. So when we're done with this question, we're going to have a log in it. Okay? So I switch this to y. I switch x and y. And now I know to undo this exponential form, I convert this to logarithmic form. So this becomes, so I'm going to write you a little note right here. Convert to log. The 2 goes down. And the second and the third items flip places. And I think you'll all see how to solve it from here. What do I do with the 3? Add it over. Yep. Log base 2 of x plus 3 is equal to my inverse. All right, so that was a little tricky because you had to know that part. Now, I'm going to do this on purpose. I'm going to go over to letter C now because letter C is the opposite. If it starts with log, what does it end with? Exponent. So this is going to become converted to exponential instead. So I am going to switch my g of x to y equals and solve. So I'm going to go x is equal to 3 log base 4 of y squared. Next, power down in front, just like we learned last week. So x is equal to 3 times 2 is 6. Log base 4 of y. I want to get the y by itself. So I could divide by 6. It doesn't simplify, but that's okay. At least it gets it out of the way. So I'm going to divide by 6. Divide by 6. Okay, I get x divided by 6 is equal to the log base 4 of y. And now last, I convert this. So as an exponent, this becomes 4 raised to the x divided by 6 is equal to y. And then I just switch this notation out. So my answer is 4 raised to the x over 6 is equal to g inverse x. You guys see the difference between those two? Okay, again, those are tricky for sure because you have to know how to undo them. So now let's go back to the middle. How do you undo E? Look at your calculator. Hint, hint. Nice. So E means I am going to be using natural log. Good. So those are inverse operations. And again, it's just like when you do a square root and a squared, a cube root and a cube. Those are inverses too. These are just harder. So I'm going to go f of x is y, and then switch x and y. So e raised to the y minus 5. And now I'm going to solve. I'll do this side first. Power down in front, natural log of both sides. Over here, I'm going to do the same thing, natural log of x. Or you can use log base e, that means the same thing as natural log, doesn't matter. Now, on the right-hand side, what happens with ln of e? Because remember, it just, yep, that's why we did it. And now to finish this, all I have to do is add the 5. So I'm going to go plus 5, and I am done. Natural log of x plus 5 is equal to f inverse x. Okay, so those are your trickier 3 inverses. How do you guys feel on those so far? Okay, good. Now, we're going to move into graphs. You've done a lot of work with a log, but you don't know what it actually looks like yet. So these are not hard, super easy too. But we're going to get into what I'm jumping ahead of myself. You have one more page, don't you? Okay, yeah, before we get to the long graph, we're going to do graphs of these inverses here first. Now, I hope you kind of have seen this from the past. Do you guys remember the line y equals x from like geometry? When you did your reflections or your proofs, like your coordinate proofs? Maybe, maybe not. The line y equals x is literally just the point 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. And what occurs is this is going to create a mirror image on the other side. So I'm going to change your directions on these just slightly. And what I want you to do is look at them. So letter I, this is my original right here. So I'm going to say this is my original. This is my line y equals x. And this dashed one right here is my inverse. And you'll see that a function's original and inverse are always a mirror image over that line in the center, y equals x. All I want you to tell me is the inverse a function or not a function? We'll just keep it at that. So this inverse, do you guys remember, is this a function? Does it pass the vertical line test? Yes or no? Yes. So I'm going to say inverse is a function. Inverse is a function. Passes vertical line test. Okay. And then I want you to just look at number 2 and tell me just the same thing. So is my inverse, which is this one, a function or not this time? So is this inverse a function? No, fails the vertical line test. That's twice. So all you're going to say is in this case, inverse is not a function. I'm going to say inverse, not function. It fails the vertical line test. Okay? How do you guys feel with those? Okay? All right. So now we're going to look at a graph of a log function, beginning with its inverse. All right, so right on over, you're going to need your calculator. So, graphing an exponential in a log equation. So it says fill out the table and graph these function values. So I'm going to do part of your table. Not really need all of this. In your graphing calculator, can you please place 2 raised to the x? So this right here is our first function. I'll do this one in purple, kind of color coordinate it for you. That goes right in your y equals. And then go to your table of values. And at 0, we should be 1. At 1, you were at 2. 2 squared is 4, and 3 squared is 8. At the other direction, this one was 1/2. This one was 1/4. And this one would be 1/8 then. So I'm just going to plot those 2 columns. So I'm going to plot -3 and 1/8. So -3 and 1/8 is like here. Next, I'm going to plot -2 and 1/4. I'm going to plot -1 and 1/2. 0, 1, 1, 2, 2, 4, and 3, 8. And this is an exponential growth function. So this is 2 raised to the power of x. So 2 raised to the x. Okay. All right, so next, number 2 says, graph the line y equals x. So the line y equals x, I'm going to switch colors. And I'm going to go 0, 0, 1, 1, 2, 2, 3, 3, all the way down here too. And connect. And label, please, because you're going to have a couple things on here. So this is y is equal to x. I'll color coordinate this one too. So this is my red one. That goes with that color. All right, and then next. It says to reflect the graph across the line y equals x. So when you reflect over y equals x, that means nothing more than switch x and y. So that's what I'm going to do. So I am going to switch my x and y from the table. So I will read these off to you so you don't have to copy them down again. All right, so if I switch these, my first point, instead of it being -3, 1/8, it's going to be 1/8 and -3. Next point, instead of -2, 1/4, it's going to be 1/4, -2. Next point, instead of -1, 1/2, it's going to be 1/2 -1. And then 0, 1 becomes 1, 0. And then 1, 2 becomes 2, 1. And then 4, 2. And then, can you fit 8, 3? 8, 1, 2, yes. Barely. All right, so I'm going to connect this. And then ask you some things about it. So we started with an exponential function, and you just found its inverse, which means what graph is this right now? What kind of graph? What's the inverse of an exponential function? A log. This is what the graph of a log function resembles. Okay? What is its equation? Wasn't this a 2 raised to the x? That means that your log equation is going to be log base 2 of x. Okay, so that's what that graph is. And all logs are always going to look the same. So this one is the log base 2 of x. All right, now some questions and some connections to help you draw. So number 5 says, what's the domain and the range for each function? So I'm going to start with my purple one first, which is my exponential. All right, domain and range. So for my first graph here, my domain, it extends forever. There's arrows on it. How do we say a domain that goes on forever? Infinity, yep, all real numbers. You are welcome to use whatever, whichever one you prefer. I'm gonna just, for simplicity, just say x is all real. But you can use infinity too, it means the same thing. So x is all reals, or you can say from -infinity to infinity. Either or is completely acceptable. That's my domain. Now I need to do my range. My range, I'm looking to see whether or not I include all y values. Or does it look like there is a boundary that this graph is staying above? What do you guys think? We're staying above something, right? What are we not hitting? 0. Good. So I say y is greater than 0. Okay. Now we're going to look at the log and draw some conclusions. So the log base 2 of x, what we established earlier is that these two functions are inverses. And inverses mean that x and y switch. The same is true for domain and range. They switch. So if this range was y is greater than 0, then this becomes the domain. And then we will confirm that on the graph. So my domain should be that x is always greater than 0. So let's go up and verify that. So go up and look. Is that true, guys? Is x always bigger than 0? Yes. Do you remember the questions where you had to check? I told you x had to be bigger than 0. This is why. Now I'm going to look at the range. What should my range now be? All reals. So they switch. That's it. So my range is going to be y such that y is all reals. Because if you look, don't you have arrows pointing up and down? I want you to make a big note. Domain and range switch. or flip, whatever you want to call it, since your log and exponent are inverses. So that will occur every single time. Okay? And then all we're going to do is, I think, just the one more graph that's on the next page. So those are going to switch. All right, how's that graph so far? Pretty good? Good. All right, next log graph. All right, so now, using your calculator, because you guys are able to do this. Again, I think I've said this before. The calculators have been improved in the past 2 years. Students now can type this in. 2 years ago, we couldn't. Okay, so you had to do some of this stuff by hand. So we need to type into the calculator the log base 3 of x. So go to your y equals, please. And I want you to type in log base 3 of x. And go right to your table of values. And I want to get some of these. All right, so in your calculator, we are going to go log base 3 of x. And I'm going to go to the table of values. And can you guys remember a couple of those? So we have 1, 0, we have 3, 1, and we have 9, 2. Hit graph. Doesn't that look just like the other log graph from the other page? Yeah, they all have the same overall shape to them, okay? So they all do. So I am going to go back and try to remember some of those. My log graph, I had the point 1, 0. I think 3, 1. 9, 2. And then I'm going to just sketch the rest of it. So we are going to go 1, 0. And 3, 1. And then it kind of heads up this direction again. Some other values that you could get from this, if you put decimals in, are like, this would be 1/9 and then -2. And then it's going to look kind of like this. All right, same overall shape as your last graph. That's what's important here. So this is the log base 3 of x. Same overall behavior as the log base 2 of x. Okay? The next thing I want to do is I want the inverse equation for g of x. So if I started this problem with a log graph, what's the inverse answer? What's the inverse of a log? What kind of function? Exponential. And if this was log base 3, what's my answer? 3 raised to the x. So go to your calculators and now type that one in. So 3 raised to the x. It's going to have the point 0, 1 in it. It's going to have the point, thank you, 1, 3. You can't fit the other one. And then it's going to have these two little guys right here. I'll just get close to 0 without approaching it, okay? So I'm going to do one of these. And this is my graph 3 raised to the power of x. And if you flipped your paper back to the first graph we did, weren't they almost identical? Yeah, they literally always look the same. So the last thing I need to put in here is my y equals x line. Are they still symmetric? Yep. I mean, none of us are perfect artists, but we do what we can. So I've got this line of symmetry right here. And my domain and range would actually be the same exact as well. Okay. Do we need the graph of the inverse in order to graph the original? What I want you to state there is that we are going to switch the x and y coordinates to graph the second function. So you can always switch your x and y coordinates to obtain the second graph if you needed to. Switch your coordinates to obtain second graph. Otherwise, you can just always still use the calculator because you guys do have that option. You don't take your calculator away from you. All right, so with a lot of graphs today, that's where we're going to stop. Because number 2, would you agree, is going to look the same anyways? Yeah, still going to have the same shape to it. So here's what I would like you to take your last 10 minutes and start. So if you flip backwards, please. I would like you to complete these problems with the inverses. Again, to stress, inverses are important. It's just the front side, right? Is there a back page to this one? I didn't think so. If you have difficulty with number 3, which you won't as soon as I say this, it asks you to find an inverse. What do we do to find an inverse? We take these coordinates and switch them. So just like write it out and switch x and y on just those 3 points. Okay? So you can have your last 10 minutes and get started on those. And we're going to do a little bit more with your graphing tomorrow. But it shouldn't be bad.